So before we start building it and programming it, let's start talking about the LM35 sensor. So this is a temperature sensor. That means when I change my temperature on the outside, so room temperature, let's say 22 degrees, then we'll have a different output we're getting from the IC. So we spoke about ICs, what they do. They have inputs, outputs, and they have some processing. So in this IC or this chip will give us the ability to read out what the temperature is in the room. So let's get started with the explanation. So in your kit, you would see this three-legged IC, we call it, three-legged with a package that looks like a half cylinder with a flat side on the other side. So the flat side is there to indicate the pin numbers. It's because when you look at IC and it's perfectly round, you won't know where pin 1 and pin 2, pin 3 start, or pin 1 and 3. 2 is always in the middle. So with the flat piece, as you can see in the image, you can see where the pin is. So when I look at the flat part, pin 1 is on the left hand side, pin 2 in the middle, and pin 3. That's the reason why they make the IC flat, so that you can know which pin is there. So you can know where the pinning is for this IC. Let's speak about the 3 pins. So here you can see already that pin 1 is my voltage. So that will give this IC power. So like you put on your lights, you need a voltage to give any electronic device some of power so that it can do its business. Like your TV needs power to watch movies, your computer needs power to play games. So power is quite the fundamental of all electronics. You need some power to get started with. And then number 2 is my output. So this is where the IC will do its magic and take the room temperature, do some processing inside, and then give you something you can use to measure the temperature. So we'll speak more about that, how we connect that to Arduino, and then how do we get the value we want. And then 3 is your ground. This goes with the voltage. When we have a supply, we always have ground, because your supply, your current always needs to flow from your voltage to your ground. So it needs to complete the path. When you don't have ground, you only have voltage. My electrons don't have anywhere to go, and your circuit won't switch on. Remember this from the basic electronics tutorials we did. If you've not watched those, go back there, just recap, and you'll understand why we need voltage and ground. Pin 1 can only handle voltages from 4 volts to 20 volts. That's very important. So you can't give it less than 4 volts, it won't work. And if you give it more than 20 volts, you might actually break it, and you don't want that. The Arduino Uno in your kit can output a maximum of 5 volts. So when you look at your board, you'll see that there's a 5 volt pin. Yeah, so if you look at your board, just below the 3.3 volts, you'll see there's 5 volts. So we can use that 5 volts to power my IC. And then we have ground and then the output. I'm going to go in more detail about the output now, because that's where the magic happens. This is where we're going to do some maths and try to understand what actually my sensor gives me, because my sensor doesn't say here's 22, 21. It gives me a voltage, and we have to interpret it to thing that we can understand, which is Celsius or Fahrenheit, depending where you are in the world, but we'll focus on Celsius. Let us chat about the output. So this is where you just have to focus a bit, because this is where the fun starts and really trying to understand how this temperature sensor works. So all you have to know basically is that for every 1 degree Celsius on the outside, this IC will output 10 millivolts. So for every 1 degree Celsius, we will read 10 millivolts, and 10 millivolts is exactly the same as 0.01 volts, and you guys are quite familiar with the volts. So we have to keep that in mind when you try to figure out. So when it's 20 degrees, you'll times by 20, and we'll have 200 millivolts. So 200 millivolts, and that is the same as 0.2 volts. So you can see once we get a voltage, we have to create our program in such a way that we can read Celsius out. So my IC does not give me this, it gives me this. So when we start programming, which we'll do later, you'll notice how we can take this value as a voltage and move it or convert it into something that we as humans understand. And that is the basics of programming, is how do we take this information of bits and voltages and analog and digital and create it in such a way that people can see it, that you can see it. Same with your computer. You see the nice games you play. That is all done with voltages, things switching on and off. But for you, it looks normal. And that's the basis of electronics and what makes it so fun. Now that we understand how this IC works, how we're going to get a voltage, so we're not going to get Celsius straight away, we're going to get a voltage in millivolts, and then we're going to have to find a way in Arduino programming to convert it back to a Celsius that you understand. And then we're also going to speak about how can we program it in such a way that we can see it on the PC. So when we take maybe a lighter, first ask your parents for a lighter. When you use it, you'll see that the temperature will increase when we take a flame close by, or maybe when you blow some air onto the IC, you'll see the temperature go up. So let's build on a breadboard now. So go to the next video and see how we build it, and then we're going to start. After that, we're going to program it. Now that we've built on our breadboard, let's program it. Let's get the temperature, make it higher, make it lower, and see if we can actually read some temperature. I'm going to go through this code step by step, nice and slow. We're going to introduce new things like declaring variables, speaking about the port, how we can read information from the Arduino to the computer. So let's just start, and if there's any questions, guys, please message me. I'll be happy to chat to you guys and ask me anything you like, and hopefully you can build with me, and then we can see what your temperature is compared to mine. It's quite hot today, so I'm guessing about 26, 25 degrees here. So let's get started. Okay, the first thing that you'll see is that I create two variables on top. We spoke about the setup before and the loop. So the setup, so we set up the board, and then the loop is where the program will keep running. On top, you'll see int val, int temp, temperature pin. So this is called variables. So it's a way for us to initialize or declare a name for a certain operation. Because let's say we spoke about when we put on the LED, we spoke about IO pin 21. So instead of saying IO pin 21, we can say I create a name called temp pin, and from now on, temp pin will be 0. So wherever I use this in my code, as you can see, temp pin, that is actually equal to 0 now. So I can write 0 here, or I can write temp pin. So we're basically creating a name where we can store values in, or store anything in. So temp pin is now equal to 0 for the rest of the code. And this is quite nice because as a human, you understand words. It's not nice when you just keep seeing numbers. And then another thing you have to see is int. So int stands for integer, and we are just telling them that this name is an integer. So integer is actually a value from minus 32,768 to 32,767. So if you ever have a number more than this, you cannot use an int, but yeah, it's sometimes unlikely. Then you have to use a float. So we'll speak about that later, don't worry too much. But integer is this range from minus 32,000 to 32,000. So our temp pin can store any value between minus 32,000 to 32,000. Then we do the same with the val. So in programming, we normally just say val for value. So you try to make it shorter because we're lazy and we don't always want to type. So int, so integer for value, and we'll use this later to store a certain value. Okay, so let's talk about the setup, because as we spoke about, the Arduino always sets up before it loops. So you'll see in the setup, we've got a new line of code, and it's called serial begin and then a number. This is used when we want the computer to communicate to Arduino to read values. You'll see we'll use it later on when we use this serial print. So we're basically going to tell the Arduino, please send information from yourself to my computer that I can read from it. So we have to set it up by saying serial begin, and 9600 is just telling it how fast you must speak. So the bigger the number, the faster it talks. So the slower the lower the number is, the slower it'll talk to the computer. But 9600 is a default one. You can keep it for now. So that's what we're going to do in the setup. We're setting it up to be able to communicate from the Arduino to the computer. If you don't do this, you can't start serial print later on, but we'll get there as we work down this code. Now the interesting part starts, where we're going to speak about how we get this value that we keep talking about, and how we read it and how do we change it. So the first thing you'll see is our valve, our value that we created at top here. So we said it's an integer valve. So this is storing like a box where I'm going to hold a value, and we're going to say this value is equal to analog read temp pin. We know temp pin is 0 because we made it 0 on top, and analog read is just a command that you can use in Arduino to read the analog value of a certain pin. So analog read temp pin, which is 0, says please read the analog value of pin 0. So if you look on the right hand side here, you see A0, A1, A2, A3, A4, A5. So we are going to read this pin now. Like we built on the breadboard earlier, that is the pin we want to read. So if we had to change this to a 1, we will read pin 1, A1. So that's how it works. You are choosing which pin you want to read. So if you made this a 2, guess, we will be A2. And so on until 5, because there's actually 6 analog outputs, so 0 is actually the first one. So it's 1, 2, 3, 4, 5, 6. So we'll keep it as 0 because we connected like that on our breadboard when we built it together. And that is basically it. So we're telling it read the analog value from pin 0. As you can see, this is a nice way of writing code because it's much easier to see my temperature pin, because I think my temperature pin is 0 and made this rather than make this a 0. So it's the same as that. But what's also nice about this is I can change the value on top here, and it will change the value throughout my whole code. So I can use this throughout my whole code, change the value on top, and it will go through all the way through the code. If I didn't have that, I have to make my 0 everywhere. If you don't understand it, guys, please send me a message. I'll be happy to chat to you guys. And that's what this line does. So it says, I've got a value, which is an integer, make it equal to. So put whatever value this is, put it in here. Make this value equal to that. That's all it is. So if this is 10, my value will be equal to 10 now. Now you'll see these values of 1024 and 5000. And you'll be like, JP, but you told me that it reads out millivolts. Why do you have to do all this funny stuff? Well, we will make a detailed tutorial about this in detail about bits and how it actually works being 10 bits, 12 bits, 16 bits. But short explanation, I'll do on the right hand side here. So Arduino has actually a 10-bit analog input. So what they do, it doesn't read a 10, a 20, a 30. It reads those values but puts it into a register. And we call this a register where it stores bits. So when a value is, let's say 40, it will be represented in a 10-bit register like this. So we'll have 10, 10, 10. Basically, you can count in binary as well. So just a short introduction. We're going to make a nice tutorial about this as well, trying to count and add and subtract in binary. But what happens is 0, 1 is 1. And 1, 0 is actually not 10, but 2. And then you can carry on like this. 1, 1 is 3, and so forth. So you can create from binary, you can create real values. And that is what the Arduino is doing. The reason for the 1024 is it's a 10-bit. So for 10-bit, you can only get values up to 1024. So if every single bit in this 10-bit register is 1, that is our highest value. So if we have 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, that is actually equal to 1024 in decimal, in integer. And that is where the 1024 comes from. And you can actually then say, to get this value, or a value that you know is the maximum that you can read, you can actually go 2 to the power of any bits that you know. So if this is a 10-bit, but it can be an 8-bit, it can be a 16-bit. So 2 to the power of 10, and you can use a calculator, but this is equal to 1024. And now we know the maximum value we can read from our Arduino is 1024. But that means nothing to us now because we need to put it in millivolts because that's what we understand. Now you see this 5000. So we discussed the 1024. That's the maximum value you can read with an analog input from a sensor or any voltage. But now we want to convert into something we understand. So imagine we have the highest value and we get 1024. That means we've got a 1 here. Because 1024 divided by 1024 is 1. And then we times by 5000. So where does that come from? is because we're making it millivolts, and 5000 millivolts is equal the same as 5 volts. So the maximum voltage that we can have on the Arduino is 5 volts. So we are creating from my value that I'm receiving, which is in kind of like in bits, 1024. So when I get 1024, I will actually read 5 volts or 5000 millivolts, and that is what we want. So we want it when it's the highest, we want the maximum temperature. So if this is lower to 0, we have 0 volts, right? So that's all it does. It's converting it into the millivolts that we require, because the maximum 1024 divided by 1024 will give me 1, and then times by 5000 millivolts will give you the maximum millivolts that we can get on the system. And for the Celsius, we want millivolt. Now that we've got a millivolts, we said that every 10 millivolts is 1 Celsius. Remember that? So there is where we divide by 10. So we make another float, we call it cell for Celsius, and we get our millivolts from the top row, the first line of code, where we convert it to a millivolt, and then we divide it by 10 to convert to Celsius, because we said every 10 millivolts is 1 Celsius, and that's how it all links together. Now I hope you understand that, because now we can see this temperature in real life. Now you remember we spoke about the serial.begin, where we said, yeah, you can begin your serial communication and you can talk at 9600, so the Arduino computer can talk to each other. And now we can use that to write information from my Arduino to my computer screen that I can see. So we've got serial.print temperature. So now we're telling the Arduino print a line on my computer screen. I'll show you guys where to see it, called temperature. And you can see we use quotation marks. So whenever we send a text, we use quotation marks. So we got quotation mark, and we can send a word test. Then it would send the word test through the USB cable to your computer. And then you can see the cell, there's no quotation marks. So this is telling us to take a value on top, a float, and send that. So that will send the value we calculate here, and this will literally send what you type. So when you don't have the quotation marks, when the quotation marks are gone, it will send the variable that you created. When you add the quotation marks, it will send the text. So we'll send the word test. So let's see what happens. So knowing that, we can see that we're going to print temperature, and then we're going to print the temperature that we calculated, Celsius. So this will be changing, and then we print C again for Celsius, and then we print an empty line just to make it cleaner. So you can see the difference as well. We've got a print line. Print prints it in straight line, and print line adds an enter at the end. So once it gets to print line, it prints the line and goes to the next one. You'll see when we start running it. So print will just print in a straight line, where print line will like have an enter key. So we'll go to the next line, next line, next line. And then we add a delay, what we've spoken about before, of 1 second. So let's program it now and see what happens. So what we have to do is, as always, tools, just check that everything's fine. We've got a COM4, and that's actually where the communication starts with serial. So when we say serial begin, we're actually talking through the COM port. So we're talking through the USB cable. And then we can just upload, wait a bit, and it's finished. So now to see what my Arduino is writing to my computer, I push this little serial monitor for groot glas, magnifying glass, and I push it, and you'll see, there we go, temperature, temperature, temperature. So you can see what's happening here is, there we wrote the first one, temperature, it's showing up there. Then we got our value Celsius, which is our 24, 25, and it feels about right. And then we got our C that we wrote here for Celsius, and then it makes a new line, and then delay for 1 second. So every second we'll get new information. So it's quite cool to see how your program, how we spoke about it, and now you see it in real life. So let me try heat it up a bit. So I'm gonna blow a bit on it. Let's see if it works. So there you can see, I blew some hot air into it and it went up to 28 degrees. You can also put your finger there. It should go up because your skin temperature is about 34 or something. So it should go higher and higher. So try this at home. Once you got a breadboard, maybe ask your parents to take a lighter next to it, not on top of it, you will break it, and then see how the temperature will go. Play around with it. If there's any questions, guys, let me know. If it's not working or something's wrong, let me know. We are here to help you guys. Like I said, there's a community, and we're just going to build some stuff together. And if you ever have questions, wondering why it's happening, something you don't understand, always ask us.